Hello, this is Micah with FOAB and 9185 Robotics. This is going to be the part 2 of our short video series on how to use Inventor to start CADing Vex robots and use it in other competition methods. In this video, we're going to go over how to create a custom part within the rules of V5RC rulebook. Basically using the dimensions and allowed dimensions for custom plastic parts. And we're going to make some changes to this assembly for an example of why we would need to do that, and include some other tips or other functions you might not be aware of in Inventor. So the first thing I need to do is I want to move this gear up into this space. But I need to create, I don't want to use a pillow bearing because I want it to connect to these two and add some triangle structure to these two parts. But I need this to spin on it or be able to constrain to it. The first thing I need to do is I need to remove the constraints that put this in place. Now you have two different options here. You can either click this and I can Control C, Control V and just make a copy of it and delete this one. Or another option I can do is I can open up on this left hand side, click the plus button, and I can remove the constraints and allow me to just move this part around now. Another thing you can do is, let's say I need room to put a custom part from here to here. I don't want to bend it, I want it to be all straight here. Another thing I can do is I can come in here, select this, and this may, if I double click on it, I can add in an offset. Now what an offset is going to do, if I make this 0.5, it's going to offset it 1/2 inch. Now that's probably a little bit too much, but you can use offsets to help move stuff around and get stuff exactly or determine how much spacing you need to put there. What I'm going to do is I'm just going to offset this by 0.0625. And that's going to be the thickness of plastic I'm going to use in this example for a custom part. So now I have a gap there of 0.625, and I'm going to use that to start drawing a part for mounting this gear. Now, a few things here. If we start looking at this, and let's say I want this gear just about here. I don't know exactly where I want it, but let's say I want it an inch and a 1.25 inches from this hole, and I want it to mount the custom part to be a triangle right here and include all of this. One thing to keep in mind is holes are 1/2 inch apart, so I can use that to start drawing my part. So just like in Inventor you can make assemblies, you can also make parts. So we're going to go to File, New, and we are going to create a standard part here. And I'm going to start by taking a look at how many holes apart I want this. I'm going to use this as my 0 point, and I'm going to go out 1/2, 1, 1.5, 2, 2.5, 3. And I'm going to do that in both directions. And I'm going to put a hole to mount here, here, and here, which should be 3 inches in both directions. So when I have my part open, my custom part, I'm going to start a 2D sketch, how all parts start, and it's going to give me a flat plane I can draw in, and it's going to open the sketch tab here. So like I said, I'm going to start with my 0. It doesn't matter which orientation I CAD this in. I'm going to start in the 0, and I'm going to use this construction line because I'm just going to start laying out my measurements I need. I know I need it to go 3 inches in this direction and 3 inches in the direction. How I'm doing is I'm clicking that point, I'm dragging it out, I'm putting a 3 in my dimension, and then clicking enter. Right clicking and clicking OK, and that gives me my 3-inch triangle here, and we can also just put a line in here to visualize this. The other thing I decided is from this hole in the middle, I need my gear to rotate on a hole that is 1.125 or 1.25 from vertically from that hole. So this just gives me the basic layout of where I need my locations for this custom part. So I'm then going to come in here, turn off my construction line, select this green dot. That's where you either have a center point or a connection of 2 points, the end of a line, so they can be super useful. I use construction lines to lay out my points. And then I'm going to come in here. I'm going to put a hole that is 0.18. And actually, I don't know if that 0.18 is correct. So how you can check this is I'm going to come into this part. I'm going to go to Tools, select the Measure option, and I'm just going to measure both this. So this is a .172 hole. And then I'm also going to measure from one face to another. That's .18. Now, depending on how tight you want your screws to fit may determine, or what type of manufacturing process you're using, whether laser or CNC, might determine what option or what you use here. I think I'm going to just stick with the .18. I'm going to put that on all of these. And I'm going to do the same thing for, seeing as I'm, let's say I'm going to use a screw joint for that gear. Doesn't really matter. This is just an example. So now that I have these holes where I don't want material, I now need to cut out where I do want material. So I suggest coming up with some sort of minimum size or minimum amount of plastic you want on the outside of a hole before it can break, depending on whether you're using polycarb or Delrin. We normally work with about 0.4, 0.5. I'm just going to do 0.5 for this tutorial. And we're even going to come into this hole on the inside of this triangle here and just do .5, just to make sure that we're all within the area that we want to be in. The next thing I'm going to do is I'm going to connect the outside here. And go to this midpoint, to this midpoint. I'm going to do the same thing down here. As you can see, now this one could be a little bit trickier. Granted, it's a 45 degrees, but we're going to pretend that it doesn't line up correctly. I'm just going to pick a point on this circle. I'm going to come down and pick a point on that circle. Now, this is not lined up correctly. As you can see, it's not straight. It's not super smooth on the transition. What you can do is there's actually constraints for drawing files. So I'm going to come in and use tangent here. I'm going to tangent constrain that, and then I'm going to come down here and I'm going to do the same thing. Looks like, oh, I got an error that says it'll overconstrain, so I must have already selected that, and it worked out there. So, as you can see here, I now have a part that looks pretty similar. The last thing I'm going to do is I'm just going to choose this trim feature and trim out this extra parts of the circles. Open that up, just like that. So this is a 2D drawing of a custom part I'm going to use. So what I can do is I can just finish the drawing file. And then I'm going to choose extrude. Now this is a 3D model tool, so not in Sketch anymore, we're in 3D model on the menu bar. We're going to click extrude. And we're just going to extrude it out .0625. Just like that for the thickness of plastic I'm going to use. And that is my custom part. The last few things we can do here, you can actually choose a different material by coming up at the top here. And I'm just going to say that it is acrylic resin black. You can also come in and change the color and do some fancy stuff. If you're doing any type of stress analysis in the future, choosing the correct material can be super important, or you're trying to determine weight of your assembly. Choosing the correct materials can be important when determining that. But I have this part here, and all I'm going to do is I'm going to come up to File, I'm going to Save As, and I'm going to go to where I have my library, and I'm going to save it to my, I included in our library a custom parts folder. I'm just going to save it there, and I'm going to call it custom triangle. Yeah, we're just going to call it custom triangle. and I save it to that custom parts folder for the year in case I need to come back and use it again or reference it. In the assembly now, I'm going to place a new component. I'm going to come into that custom parts file, take our custom triangle here, and I want to get it somewhat lined up so it's easier to constrain. So I'm going to rotate it around the Y. Do that 2 more times. Okay, I'm just going to place that. What I'm going to do is I'm just going to come in here, get this constrained real quick. Should become fairly easy. The more you do it, the better you can move around, and the faster you get at this. Another thing I'm doing is I'm clicking enter as soon as I click, just to approve it. And then finally, I'm going to constrain that. Just like that. So with this video, we learned some more tools and uses inside of the last step of an assembly is to go up here to File. We're going to Save As. And we are going to save this to Robot 1, and we're going to call it Test. I'm going to save this assembly. Very important when working with assemblies and parts. If you're making a bunch of changes, save often. Inventor even tells you to save if it's been a while. I highly recommend listening and saving. Now that you've saved your assembly, you've learned the basics of constraining parts together to start putting together robots, how to create a custom part within the V5RC rules that is legal, and how to utilize that part with other tools and get it working within your assembly and in your robot moving forward. Remember to save often, and in the next video we'll be going over some more advanced assembly constraints.